Welcome to VINDAL'S Academy. We are doing 2024 Jamb Utme revision questions. So these are some of the previous questions on the last Jamb for physics, and we know that some of them will be repeated. So let's take it on with the first question. But remember, it is very noble to always hit the subscribe button, like this video, and share to some of the students. All right, we have the first question, which is on pressure. Okay, the question says on a particular hot day, the temperature is 40 degrees Celsius and the partial pressure of water vapor in the air is 38.8 millimeter mercury. What is the relative humidity? And the table is there. So looking at this question is a question of relative humidity, and we know that relative humidity is given as on the context of this question, I'm going to be saying is the partial pressure of water, all divided by the saturated vapor pressure of water, then multiply by 100% over 1. Now, if you look at the question, the partial pressure of water is, from the table, is at 38.8 millimeter mercury. So that one is 38.8 millimeter mercury divided by the at SVP. At SVP we have 55.3, then multiply by 100 over 1, and this is the same thing as the relative humidity. Okay, when you simplify it, 38.8 divided by 55.3 is going to give you 0.7, then multiply it by 100, you are going to be having 70%. Number 2 question says, this is a theory question. They say that when a sound wave passes from air into water, what happened? Option A says the speed and frequency increases but wavelength remain the same. Option B says speed and wavelength increase but its frequency remain the same. Then C says speed remain the same. Now, if you go to the topic of refractive index, whereby we say that refractive index is given as the speed, which is V of A all over V of B. You can also say that refractive index is wavelength of A all over wavelength of B. But you can never see a refractive index where we say that frequency of A all over frequency of B. So that means that frequency does not change. That means velocity can change, wavelength can change, but frequency does not change. So which of the questions where we say that frequency is the same is going to be the right option. So speed and wavelength increase but frequency remains the same. To the next one, it said the light of wavelength 5, the wavelength is 589 nm. Whenever you see this n, nano, and that nano is the same thing as 10 raised to the power -9. is a prefix. Is a prefix in physics, in sciences. So it said the light wave of 589 nanometer in vacuum passes through a piece of fused quartz of index. Refractive index is n, is given as 1.458. What is the frequency of the light in fused quartz? And that is speed of light is given as 3.00 times 10 raised to the power 8 meter per second. All right. What we are going to do is still the same thing we did, just like what we did in the previous, where we consider that the frequency. Let me clean this part. Now, if we say that the refractive index is given as change in the wavelength, that is, let's say wavelength for A all over wavelength for B. Now, from this question, we also know that refractive index of a medium is going to be that velocity for the first medium all over velocity for the second medium. All right, what we are going to have is, but then we also know that at this point, this VA, I'm going to call it the velocity through the vacuum. You know, the vacuum is the empty space. In physics, we call it just the speed of sound in air. I mean the speed of light in air, not sound, and that is C. And then I'm using the other medium, which is velocity of light in that medium. I'm going to call it VB. Remember what I said, VA is now representing C because it's the speed of light in the vacuum. So in this case, what I'm going to start by doing is, first, using this formula right now, I'm going to say that velocity of sound in a medium is equal to the speed of light in a vacuum all over the speed of light, all over the refractive index. Now the speed of light is 17 as 3 times 10 raised to the power 8 all over. Then the speed of light in that vacuum is going to be this divided by that of the refractive index, and refractive index is given as 1.458. Now we are going to simplify that. And when you divide that, you are going to have 2.06. 3 divided by 1.458 is 2.06. Then times 10 raised to the power 8. And this is going to be meters per second. So I have gotten the speed of light in the medium, and that medium is fused quartz. Now the next thing I'm going to do is to find the wavelength. The same thing we are going to do here is going to be that the wavelength through that particular medium B, the medium B, I'm using the medium B as the medium of the fused quartz, is still going to be the speed of the wavelength through the vacuum, which I'm going to give as wavelength naught divided by the refractive index, which is 1.458. all right, look at what I'm doing. What I'm doing is just using this formula and this formula to get the value of the frequency of light in that medium. So I cannot do that because according to the formula, the speed of light in any medium is given as the frequency of light multiplied by the wavelength of that medium. So if this medium is medium B, then I'm going to have this for B. So but the question did not give me the value of this speed for that medium in the fused quartz. It is also did not give me the wavelength in that fused quartz. So what I'm doing is first find VB and then find lambda B. I have found VB, which is the speed of light in the fused quartz. I'm going to find the wavelength in that same medium before I can apply this formula. So that is the whole thing I am doing. All right, so taking it up, we are going to have that this one now is going to be the wavelength at that point is given as 5. From the question we have 589 times 10 raised to the power minus 9 in meter is nanometer because of that small n which I told you. Then divide by 1.458. If you do this very well, you are going to have 404. Okay, let me just put it in n meter, not considering this value, just calling it ordinary n for easy calculation. So I have found the wavelength. So the next thing I'm going to do now is that f is equal to that frequency multiplied the wavelength. So the value is going to be, the frequency is already given as f is going to be equal to VB all over lambda B, and this is going to be 2.06 times 10 raised to the power 8 divided by 404 times 10 raised to the power minus 9, and the answer is given as 5.09 times 10 raised to power minus 14 hertz. All right, moving to the next question. A lorry accelerates uniformly in a straight line with acceleration of 4 meters per second square and covers a distance of 250 meters in a time interval of 10 seconds. How far will it travel in the next 10 seconds? All right, I'm going to be using this formula ut plus half at square. Now, using this formula, the s there represents the distance. So I'm going to have 250 is equal to, the time is 10, I don't know my initial speed, plus half, that is going to be 2 times, the time is already 10 square. Remember what I did, 1 over 2 times 4 is same thing as 2, so that is why I put this 2. So this is my, is going to be, if I simplify this, I'm going to have 250 minus 200, which is equal to 10u. So I'm going to say that my u is going to be equal to 50 all over 10, which is 5 meters per second. So this is the initial speed. All right, now I've gotten my initial speed to be 5 meters per second. I'm going to have, for the next 10 seconds, I'm going to say that t is going to be 20 seconds, because the first 10 seconds, next time is going to be at 20. Next means to add. Now, at next 10 seconds, the total time will be 20 seconds. So what I will do now is repeat the process by saying s is equal to ut plus half at square. Now s, I'm looking for s because I'm looking for the distance in the next 10 seconds. U is already given as 5 times 10. T is going to be 20 plus half times acceleration there is 4 times t is 20 square. So if I simplify this very well, I'm going to have that s is going to be, this is 100 plus 2 times 400, and this is 800. Everything is going to be 900 meters. But 900 minus 250, remember the first one we got was 250. No, the distance of the first part is 250. 900 minus 250 is going to be 650 meters. All right, and the option there is up. So this question is theory question. Say, which of the following are the correct SI unit of the quantities indicated? Torque. The SI unit of torque is Newton meter. The SI unit of momentum is this, power is this. So my option is B, and that B is torque, which is Newton meter, and 4, which is pressure, kilogram meters minus 2. So this is correct. In number 6, what is the amount of heat required to raise the temperature of the mass is given as 0.02 kg of ice cube from minus 10 degrees Celsius to 10 degree. I'm going to use a graph to explain this concept. So I'm going to have, this is the first, I'm going to say that if at this point we have 10 degree minus 10 degrees Celsius, what will happen is this: there is a latent heat. At that point, there will be increment. When you add heat to this, it will increase to this point, and this is 0 degrees Celsius. When it reaches here, it won't go up again, it will never. What it will do is move this part, then increase again to this point, which is 10 degrees Celsius. So what quantity of heat will raise it from here all the way to this part? Take this direction again and then get to this point. So this is going to be MC change in theta, this is going to be ML, and this is going to be MC change in theta. Now, what is MC change in theta? This is the quantity of heat required to raise the temperature from -10 to 0. Then at this point, which is where there is a change of phase between solid and liquid, we call it latent heat of fusion. Then from 0 then to 10 degrees Celsius. So what I'm going to do right now is I'm going to have that. I'm going to start with, let me clean up here. Alright, let me start with the first part from minus 10 degrees Celsius to 0 degrees Celsius, and that is going to be mass of the ice. Mass of the ice which is going to be 0.02 times specific heat capacity of the ice, which is 2100, times change in temperature from -10 to 0 is something as 10. Do I have a calculator? Okay, so this is the first stage. I'm going to add another stage, which is mass of that same ice, which is 0.02 times latent heat of fusion. From the question, latent of heat fusion is given as 334 times, sorry, I'm not expressing it in this, I'm expressing it in an ordinary number. So this is the what has happened at the change of phase, plus another one that happened from 0 to 10, which is going to be 0.02 times the specific heat capacity of the liquid or water, which is 4200, then times change in temperature from 0 to 10, which is 10. So if I add all this together, I am supposed to have the quantity of heat required to raise it from -10 to 10. So let's go 0.02 times 2100 times 10. So the first one is 420 plus, let's do this as well, 0.02 times 334123, so which is 6680 plus 0.02 times 4200 times 10, which is 840. So if I add all this, I have 840 plus 420 plus 6680. So total quantity of heat is 7940 joules. So which of the options? Object weighing 420 Newton in air is immersed in water after being tied to a string connected to a balance. The scale now reads 380 Newton. Find the density of the object. Density of water is given as 1000 kg per meter cube, and acceleration due to gravity is 9.8 meters per second square. Alright, first of all, I'm going to start with upthrust, which is given as weight in air. Weight in air is 420 Newton. That is weight in air. Now, weight in liquid, when it is immersed in liquid, is reading 380. So the upthrust is what? The upthrust is going to be 40 Newton. But remember, what is upthrust? Upthrust is the same thing as the weight of the fluid displaced. Weight of the fluid displaced is same thing as upthrust. Remember that upthrust. Also remember that upthrust is V G and density of the liquid. This is density of the liquid. This is volume of the liquid displaced, which is something as the volume of the object. So this is going to be 40 is equal to, I'm looking for that V, volume of the liquid displaced, times G is 9.8 times density is 1000. So volume of the liquid displaced is going to be 40 divided by this is going to be 940 divided by 9800. So the volume, sorry, 9800. So the volume of the liquid displaced is going to be 0.004. I mean 0.0041 meter cube. All right, so now this is the volume of the liquid displaced. It's still the same thing as the volume of the object according to Archimedes principle, but then the mass of the body, sorry, let me put this in. But then the mass of the body is going to be, mass of the body is going to be 420 divided by 9.8. That is what mass is. I mean weight divided by acceleration due to gravity, which is 420 divided by 9.8. The mass of the body is something as 442.86, and this is kilogram. But then what is the density of the object according to the question? Density of the object is going to be, let's finish it here please. Density of the object is going to be mass of the object all over volume of the object. So density of the object is going to, mass of the object is 42.86 divided by volume of the object, which is 0.0041. and what did you get? Let's divide it. You have 42.8 divided by 0.0041, which is 10439. So I think the option, okay, number 8. A wire of radius 0.2 millimeter is extended by 0.5% of its length when supported by a load of 1.5 kg. Determine the Young modulus for the material of the wire. Take G as 10. All right. First of all, I'm going to see that E extension is 0.5 over 100 times L. This is E, and then E is going to be the same thing as 0.005 L. That is my extension. But then my radius is going to be, if you convert it to meter, it's going to be 2 times 10 raised to power minus 4 in meter, because I'm converting this. If you convert millimeter to meter, you divide it by 1000. So when you have 0.2 divided by 1000, you are going to have 0.1234. That is what you are going to have. So that is why I'm having that value, because I'm expressing my own in standard form. All right, so after that I have my mass, and what I will do right now is to give you the formula. Remember, Young modulus is given as FL all over AE. This is the formula for Young modulus. But remember that F is my weight, because it's mass times acceleration due to gravity, and that is going to be that 15 times 10 is going to be my force. And remember, one more thing we need to consider is what is the area. The area is pi r square, so that I'll put the area here. Pi is 22/7 times r is is 2 times 10 raised to the power minus 4 all squared. Sorry, this is going to be equal to 1.26 times 10 raised to the power minus 7 meter square. This is my A. Now I have gotten all these things. I'm going to put them. This is force is 15 times L. Yes, all over. Area is 1.2 times 10 raised to the power minus 7 times extension L is something like 0.005 L. So remember, L will cancel L, and then when you simplify properly, you now have 2.4 times 10 raised to the power 10 Newton meters per minus 2. All right, sorry for that mix up in statement. So that is that. Let's go to number 9. Number 9 is saying, which of the following statements regarding the application of electrical conduction via gas is are correct? Electrical conduction in gas is supplied. So the option is C, because it's going to be I, and IV. That is the option. Let's go to number 10. Number 10, a car lifts compressed air is at a force on a small piston of circular cross-section having radius of R1 equal to 10 cm. This pressure is transmitted by an incompressible liquid to a second piston of radius R2 equals to 20 cm. What force must the compressed air exert on the small piston in order to lift a car weighing 15,500 Newton? All right, so what we need here is to find what is that A. At this point, I'm going to say that I need my A1. So what is A1? So, but before that, F1 over A1 is going to be equal to F2 over A2. That is just it. But then F1 is what I'm looking for. It's going to be equal to F2 times A1 all over A2. Now F2 is given as 15,500 times A1. A1 is going to be pi R square. What is my R? What is my R? In this question, R is 10 cm. 10 cm. 10 cm, if you divide it by 100, you have 0.1 now. So this is 0.1. 0.1. Sorry, let me clean this. This is 0.1 squared. That is the area. All over pi bracket. This is 0.2 all squared. And this is given as F1. I'm looking for the force. Then this is going to be, if you do this very well, pi, we cancel pi. 15,500 times 0.1 square divided by 0.2 square, you are going to be having 3875 Newton. Okay, let's go to number 11. Number 11, they say that a 200 kg load is raised. A 200 kg load is raised using a 110 meter long lever, as shown in the diagram above or beside. The load is 10 meters. The load is 10 meters from the pivot P. If the efficiency of the lever is 80%, find the effort E required to lift the load. Given efficiency is 80, so I'm going to say, but efficiency is given as work output divided by work input, then times 100%. But then the work output, work done work done by the load or on the load is given at, or let's say work done, or which is the output. The work done is actually the output because the machine is used to do the work, and it's going to be force times 10. That force is going to be 200 times 10. You know why? Because work is force times distance, but force is mass times acceleration due to gravity times s. So it's typically mgh, which is something as 200 times 10 times 10. Why the next 10? That 10 is the distance. The load is 10 meters from the pivot, the distance it is from the turning point. So the work output is going to be 2, 3, 4, 20 joules. Now, what are we looking for? The effort. All right. Now, work done by the effort, which is the same thing as work input, because effort is the input. Work input is going to be the effort, which is the force. Remember, force is also effort, and work is force times distance times 100, because out of the 100, you know, this is the length. Out of the 110, 10 cm or 10 meter has been taken by the load. So the remaining, which is 100, is now taken by the effort. So this is going to be 100 E, which is the effort. Now, if I put it in here, I'm going to say that 80 is equal to 20,000, not 2000, all over 100 E times 100%. That is 100 over 1. Now, this 0 is cancelling this 0. These two zeros is cancelling these two zeros. This is going to be 8E is equal to, 8 times E is equal to this. Then E is going to be equal to 2000 divided by 8, and then which is 250 Newton. All right, let's go to number 12. Number 12 is a theory question. Then number 12 says, which process is responsible for production of energy in stars? That one is very simple one. It's nuclear fusion. It's this fusion. This is fusion, because this fusion has to do with combining plus of the well, I wonder why I'm using this, but then combination of nucleus of a nuclear element. All right, the next one is number 13. In number 13, a parallel plate capacitor separated by an air gap is made of 0.8 meter square thin plates and 20 millimeter apart. If it is connected to 120 volt battery, what is the charge on the plate? Take E naught 8.85 times 10 raised to power minus 12 F per meter. All right, a parallel plate. Let's assume now we have this plate. Then we also have this. These are the two plates, and these two plates are connected. One may be plus, and the other one is this, and then electric field is built in space, and this is the gap. And they say if the distance between them is, the distance is 20 millimeter apart. All right, that is the diagram, and what I'm going to say is C, which is the constant. Remember, quantity of charge is equal to CV. This is the quantity of charge, this is C, and this is the capacitance. of the capacitor, or capacitance of the capacitor. Now this is going to be E naught A divided by D. Then after doing this, whatever I get at C, I will substitute it in here before I get my thing. So the quantity of charge stored here is what you are looking for. All right, I'm cleaning up while we take up the solution. Which you are using? 2021, Abi?
Yeah.
Correct. Continue, I'm coming. All right, I'm having that C is equal to E naught is something as 8.85 times 10 raised to the power minus 12 times area is given as 0.8 all divided by D, which is 20 divided by 1000, to convert it to meter. So when you multiply this, you have 7.08 times 10 raised to the power minus 12 all divided by 0.02. all right, so this continue. This is, if this divided by 0.02, I'm going to have 3.54 times 10 raised to the power minus 12. This is the coulomb, and this is in farad because it's measured in farad. So after that, I'm going to say that Q is equal to CV. V is 120 times C is already given as 3.54 times 10 raised to the power minus 12. Q is equal to 42.5 times 10 raised to the power minus 9 coulomb, or this is going to be 42.5 nanocoulomb. All right, because everything here is going to be your N nano. All right, going to the number 14. Calculate the absolute pressure at the bottom of a lake at a depth of 32.8 meters. Absolute, assuming that the density of the water is 1000 and the air above is at a pressure of 101.3 kPa. That PA is pressure, that K is 1000. Remember, the density that having minus 3 is not supposed to be. Density is just 1000 kilogram per meter cube. So what I'm going to do is, you remember the question. If this is a lake, from here to here is the depth of the lake. This is the surface of the lake. The total distance, or the length, which is something as 32.8, is the height. There is a pressure according to this height. So what I'm going to do is, now the pressure acting at the surface is the atmospheric pressure, which I'm going to call, okay, I can call it anything. Let me just call it P. This is the pressure mounting on this liquid, and there is another pressure at the bottom of the liquid, and the final pressure is the one due to this height. Now what I'm going to say is that the pressure at the bottom, which is PB, is equal to the pressure of the atmosphere plus the pressure due to height, which I'm going to say is going to be GH density, because this is because pressure due to that height is given as GH, and density is this way. It's this way. Good. All right, the pressure of the atmosphere, PB, is equal to, that pressure of the atmosphere is given as 101.3, then plus the pressure of, due to this height, I'm going to solve it here, please. Let me say pressure due to that height is given as G, which is 10 times, yes, G should be given as 10, then times height, which is 32.8, then times 1000. So everything is going to be 321,440. Now, but I have to divide it by 1000. to convert it to K, which is going to be 321.44 K. So this is what I'm going to add here, 321.44 kp. So the total pressure of at the bottom is given as 422.74 K. Number 15. The distance between two parallel horizontal wires carrying the same current in opposite direction is 20 cm. If the force between the wires per unit length is 1 times 10 raised to minus 4 Newton per meter, calculate the current carried by the wires. Is the force between the wires attractive or repulsive? Take mu naught as 4 pi times 10 raised to minus 7 Newton per current. Alright, in this question we are going to use this formula. I'm going to say that F is equal to BIL sine theta. But I am saying F per length is given as BIL. No, L is not there. L is gone. So sine theta. But what is this B? The field. That B is given as mu naught current divided by 2 pi d. This, it could also be 2 pi r. So if I substitute it inside this equation, I'm going to have that F over L is equal to u naught I, then I, another I, all over 2 pi d. Now I'm going to substitute the values. But the current is the same, so I'm going to have u naught I squared all over 2 pi d, and this is going to be, everything about F over L is already given in the question as length per meter, force per unit length, which is 1 times 10 raised to minus 4, which is equal to, the value of this is already given in the question. It is the same thing as 4 pi times 10 raised to minus 7, then times the value of the current. Okay, I'm looking for current, which is I squared, divided by 2 times pi times, so remember pi is cancelling pi, 2 is cancelling 4, becoming 2. Then d, what is the d? The d, which is the length, is 20 cm. Which is 20 cm is something as 0.2, and everything here is going to be 2 times 10 raised to okay, 2 divided by 0.2 is 10 times 10 raised to minus 7. Okay, let me clean this part. Now coming to this part, we have 1 times 10 raised to minus 4 is equal to I squared times 10 times 10 raised to minus 7. Alright, so I is equal to 10 raised to 4 minus 4 divided by 10 raised to minus 8. Okay, it can't be minus 8, it's 2. It's 2. So this is going to be 10 raised to minus 4 plus 6, which is equal to 10 raised to 2. And sorry, this is square. For me to get current, I'm going to say square root of 100, which is 10 ampere. Now the current is 10 ampere. Now the question is, is it going to be repulsive or is it going to be attractive? Since they are moving in opposite direction, they will be repulsive. So the answer. The next, the number of holes in an intrinsic semiconductor is equal to the number of free electrons. That of 17 is a battery of EMF 12.0 volts and internal resistance of 1 ohm is connected to an external resistor of 3.0 ohm. Find the power delivered by the battery. The power delivered by the battery. Let's first find, okay, in that case, you know that E is equal to capital V plus small v. Then this is E is equal to I capital R plus, this is lost voltage, we call it lost voltage small v, which is I multiplied by small r. So according to this question, we have capital R and small r. So this is 1, this is 12. EMF is given as 12. I don't know the current, but I know the capital R to be 3 and the small r to be 1. So that means that the current is 12 over 4, which is 3 ampere. Current is 3 ampere. So in this case, the power because we are asked to find the power delivered by the battery. So power in this case is going to be I square R. This is the power for the internal resistor, and there is another power for the external resistor, which is I square multiplied by capital R. So this one is going to be 9 times 1, which is 9, and this is going to be 9 times 3, which is 27. If you add the two of them, total power delivered is going to be 36 watts. In number 18, we said a simple pendulum has a period of 5.77 seconds. When the pendulum is shortened by 3 meters, the period is 4.60 seconds. Calculate the new length of the pendulum. Alright, so I'm going to say that T square is directly proportional to length. And this simply means that T square is equal to KL, and that means that K is equal to T square all over L is the constant. Now that simply means that I can have T square 1 all over L1, which is equal to T square 2 all over L2. Now going back to the question, a simple pendulum has a period of this. That means T1 is 5.77 seconds. When the pendulum is shortened by 3, so L1 is L, I don't know L1, but L2 is shortened, that means L minus 3. So T2 is what? 4.60, because that is the time the seconds reduced. So let's go, we have 5.77 squared. Please remember everything is squaring, all over L, and this is equal to 4.60 all squared all over L minus 3. If I clear the fraction, I'm going to have that 5.7 square is something as 33.29 all over L, which is equal to 4.6 square is 21.16 all over L minus 3. I'm going to clear the fraction. I'm going to clear the fraction. I'm having 33.29 times, okay, L minus 3, and this is equal to 21.16 times L. So clearing everything very well, I'm going to have that this is 33.29 L minus and 33.29 times 3 is going to be 98. Okay, sorry, it's 99.8 L. Sorry, it shouldn't be L. Wait, let me clear this place. This is going to be 99.87, which is equal to 21.16 L. So I'm collecting like terms, taking all L to one side. 33.29 L minus 21.6 L. 21.16 L, which is equal to 99.87. So 33.29 minus 21.16 is giving me 12.13 L, which is equal to 99.87. If I divide both sides, I have that L is equal to 8.23 meters. Alright, but that's not the answer for new length. New length is L minus 3. So I'm going to say 8.23 minus 3. And answer here is 5.23 meters. Alright, that is for that question. Number 19. The surface temperature of a swimming pool on a warm day is 25 degrees Celsius and the temperature at the bottom is 15 degrees Celsius. If the swimming pool has a surface area of 620 meters square and a depth of 1.5 meter, find the rate at which energy is transferred by conduction from the surface to the bottom of the swimming pool. Thermal conductivity of water is K equal to 0.6071 watts per meter per Kelvin. Alright, the question here is that power is equal to Ka change in theta all divided by L. But remember that power is something as energy over time. And the energy in this case can be quantity of heat all over time. They are all the same thing. So I'm going to say that Q over T is equal to Ka change in theta all over L. So which of these values are we going to put here? Now, since I'm looking for Q over T, I'm going to have that K is 0.6071 times area is 620 times change in temperature is 10, right? Because 25 minus 15 is 10 divided by length. What is the original length? What is the length there? One point five. You use your straightforward calculation, you see that we have 2500 watts, which is something as 2.5 k watts. Now a boy throws a ball vertically upward with an initial velocity of 50. What is the velocity of the ball on striking the ground? Ball was thrown vertically upward, so I'm using this one equal to U plus minus GT. Let me first find the time it takes to reach the maximum height. V is 0, so U is initial velocity is 50, so this is 0 equal to 50 minus 10t, so this is 10t is equal to 50. T is 5 seconds. This is the time taken to reach the maximum height. But what am I looking for? The velocity with which it will use to strike the ground. So in this same case, I'm going to use this formula to find the velocity. V is equal to U plus GT, because at this point it is falling down. But because it's falling down from maximum height, U is 0. So V is going to be equal to 10 times 5, which is 50 meters per second. This is the first 20. Ladies and gentlemen, thank you for being part of this lesson as we finish the first 20 in 2024 Jamb Utme revision questions on physics. Have a good day, and I wish you luck in your exam. Remember, part 2 is coming, which is going to be from 20 to 40.